Do you have algebra tiles?
I do. Sometimes when we get into big idea questions, I actually give the questions names. And I find that if we name a question, it also helps us remember how to do them. Like, oh, it's one of those kind of thing. But instead of using one of those 15 different times, this one we're going to call multi-revolution multi-revolution question. And I might be the only person who calls it that in the whole world. I don't know. Right? If you type it into YouTube, you might just get my videos and be like, oh, I'm not sure. Okay. Why do we call it a multi-revolution question? I'm going to need to pull out one of my unit circles here to help us with this. And how do we solve this? Okay. So on one side here, I'm going to give you some steps. Steps are always nice and helpful, especially when you're studying to review something. How are we going to do the multi-revolution question? And what does it look like with the actual question? So we'll do the step and the question sort of simultaneously so you can see. Okay? Step number 1. We are going to rewrite the domain for, and then I'm putting in quotation marks 3x, because sometimes the multi-revolution question will have a 2x, sometimes it'll have a 4x, sometimes it'll have a 5x. So we're rewriting, because our question has a 3x, we're going to rewrite the domain for 3x. What does this mean? Well, if x is between 0 and 2 pi, does it make sense that 3x's would be between 0 and 6 pi? Okay, this is like if I got you to pick a number between 1 and 10, and everybody picks a number between 1 and 10, and then I told you to multiply it by 3. Does it make sense that everybody's numbers would be between 3 and 30? Except for those that have trouble with mental math. Maybe there's, right? But if we did our mental math, right, everybody's numbers now, if they pick between 1 and 10, and I said multiply by 3, they're now between 3 and 30. So if x was between 0 and 2 pi, 3x's would be between 0 and 6 pi. And if we think about our unit circle, 0 and 6 pi is once, twice, 3 times around the circle. And that's why I came up with the name multi-revolution, because we're going around the circle more than once. We're going 3 times around our circle for this question. So number 1 step, rewrite the domain for 3x. Okay? Step 2, solve for 3x over its domain. So when we're solving for 3x, we're going to write 3x equals. Just like if this was theta, if it was just a theta, you would write theta equals. If it was just an x, you would write x equals. It's a 3x, so we write 3x equals. Is sine ever equal to 0? Sine is your y-coordinate. When does that happen? Y-coordinate at 0, right? That's your first one? Anywhere else? Yes, at pi. And all the way around? 2 pi. That's once around your circle. How many times do we have to go around our circle? Up to 6 pi 3 times. So we'd also have 3 pi and 4 pi. That would be the second time around. Third time around would be 5 pi and 6 pi. But you know what? This is where the textbook got a little bit mean. Do you see how the textbook was tricky on this one? I can't write the 6 pi because the textbook did not include an equal sign there. So I don't have an equal sign there, so 6 pi can't be included. So we rewrote the domain for 3x. We solved for 3x over its domain, which was 3 times around. And then step 3. Now we can solve for x. If 3x's was equal to this, each of those, does it make sense that you could find 1x by dividing each of them by 3? If 3x is 0, then 1x is 0. If 3x's was pi, then 1x would be pi divided by 3. 2 pi divided by 3. 3 pi divided by 3. You could reduce that if you wanted. But all of them are going to get divided by 3. And in the end, all of those answers are between 0 and 2 pi. The original question solved for x between 0 and 2 pi. 5 pi over 3 is in quadrant 4, but still less than 2 pi. So multi-revolution question, you'll get more answers, because really what's happened with that 3, if you think about transformations, that's a horizontal compression. It got squished. And as it got squished, there's going to be more up and downs between 0 and 2 pi, and more solutions that are happening. Here, just because we have Desmos and it's so much fun. I'm going to type in y equals sine 3x. Whoops, I don't need a bracket. And drag it so that you can see it. In fact, I am going to play around with my x-axis and just look at 0. To 2 pi. Can I write pi? Look at that! I love this program. Look at that. And then if I wrote, when is it equal to 0? Well, those are my x-intercepts. It's going to be 1 here, 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 obviously 1 here. This one, this one, this one, this one. How nice is Desmos that it even gave me... Oh. Are you okay that this first one's at 0, 0? I so badly want to click on it, but it's not letting me. I'll click on these ones. Right? Normally a coast graph has 1 period in between 0 and 2 pi. Now it has 1, 2, 3 periods in between 0 and 2 pi. And so we get more solutions because of that horizontal compression. Then, part B says, you found your answers. I know it said state to the nearest hundredth, but we didn't even need our calculator. We could do exact values are always better. Anyways, what were our steps for the general solution? Our steps for the general solution were solve between 0 and 2 pi. We've done that. And then the general solution would be, you can take each of your answers. I know this is a little annoying to write them all again. Right? But what would math class be without being a little bit annoyed? Add 2k pi to each of them. And define k as an integer. And so now you've written your general solution. Using the steps that we had before. General solution, solve for 0 to 2 pi first, then add 2k pi. Maybe we'll warm up with another one of these tomorrow. but I'll get you to circle questions. Just question number 10.